Hello, everybody. I'm David Flynn, the CEO of Hammerspace. Glad to be here today. Now we're going to talk about the incorporation of machine learning, continuous optimization, how that works to manage or to automate completely the concerns about how does your data map into the infrastructure. So we like to think of ourselves as cloudifying the world of unstructured data, the world of shared file data, because shared file really didn't make the leap to cloud. It kind of got abandoned. You're either doing, block devices on the one hand where you need performance, and object storage where you need geoscale and convenience in managing it. We're bringing those two worlds together by being able to use a shared file system semantic at cloud scale and with this richness. But at the heart of that is then how do you automate the realization of the data across the infrastructure? We've already talked about how objectives can be formulated from the metadata and ultimately make statements like, I need this level of performance, I need this level of durability, I need it to be available at this site, I need it at that site, I need it to be sovereign only to this continent, so you have data sovereignty, performance, reliability, business continuity. All of those things can be expressed in metadata. It is, after all, data about the data, and some of the most important because it's saying how you want the data cared for. But those intents, by the way, that's part of the power, is that this is declarative. You're stating what you want and how important it is. Only with an intent-based model, only with a declarative model, can you have the hope of automating it. If it's a procedural model of I take this and I copy it from here to here and I take this and copy it from here to here, you can't automate it. That's why it's a complete pivot from the copying between silos to an abstraction where you can do that. The way that orchestration works, so if this is the metadata layer that we've been talking about to date, and this is the virtualization layer where it gives us the ability to move data around, the mechanics of moving it around. This is the layer that does the orchestration. So this is what would correspond to the industry term, your hybrid cloud data management. But we think it's really unique when that hybrid cloud data management is the bolting of a rich metadata layer with a dynamic virtualization that lets you automatically rebalance and move things around. So orchestration. The fundamental model that we use for our machine learning is to simulate a market economy, to run a financial arbitrage model where the storage containers, think of them like big apartment complexes, and they have amenities other than just square footage. There are other things they sell, in this case performance of its different flavors, and those resources are limited. So we're using the enlightened self-interest model, the Adam Smith kind of resources get allocated most efficiently when folks are operating out of their own self-interest in a fair world without cheating. And of course we can make sure they don't cheat. So we run a simulation of the greedy landlord and the tenants, where the tenants are the data objects. Those data objects have their taste. I want to be here, I need this, I need that, and they have the value of getting that. So you can actually think of those objectives as getting boiled down to more of a service level agreement where you've established some agreed upon compensation rate for achieving that objective. Once you have boiled it down to agreed upon value, then the simulation can use that value to arbitrate whose interests outweigh who. It's the almighty dollar, right? This is all hypothetical. I don't want to come across as like the greedy capitalist here, but the fact of the matter is free markets work quite well at the distribution of resources. And that's exactly how this financial arbitrage works. The storage containers must compete within their sphere to attract the data items, and the data items must compete within their sphere against the other data items to bid on those resources. In the end, this makes for a an optimal allocation of resources, a slope descent optimizer, where the hidden variables are the going price rates for the different pools of limited resources. Is that making sense? So the cool thing is this handles in one fell swoop things like promotion and demotion and load balancing, the resilvering where you to lose a volume and it's got to spin up new copies. All of those behaviors fall naturally out of this competitive market simulation. Let me give you a couple of examples of things that happen to be somewhat counterintuitive that show that this is a multidimensional problem that a system can actually handle better than humans. You would typically take a performance tier, say you have flash devices, and you would allocate your high performance demanding objects to that high performance tier. Well, it's not uncommon though, even with it being a high performance density, that your data objects consume all of the available performance before all of the space is used up. So if you think of these as roughly two dimensions of resources, one is the capacity and the other is the performance, you don't want to run out of performance first, because then you're wasting capacity. The key to efficient usage of resources is to use them all up at the same time, or to use them up evenly. So in this simulation, performance is priced separately than capacity, and even bandwidth to copy things between them is an auctioned resource. So what happens is, for example, if I have a volume that I am going to take offline, or that went offline, on its own unexpectedly, the system was keeping copies of data there for something. It needs to spin up new instances. Well, with this financial arbitrage, those data objects who were depending on this to receive some value are suddenly going to urgently need some, another place to another residence, right? And however, the pipes that are used to make copies from wherever else they have those copies might get flooded. In other words, there's a storm, a train wreck where everybody wants out at the same time. Everybody needs to make additional copies. You need to resilver the world. And in this scenario, some interesting things happen. There might be a perfect new, shiny new apartment complex where they all want to go. But because they all urgently need it, and the bandwidth to get there might be clogged by higher priority items, what happens is guys further down the list will take other routes and maybe even go to less favorable destinations just to get their durability, just to get their reliability issues managed. And then as the system gets things moved, it ends up, maybe shifting them from where they went to out of urgency to where they can go to for a better fit. Is that making sense? So a distributed rebuild is an inherent behavior, and even a distributed rebuild that goes through suboptimal intermediate states so that it can get the protection first before it gets to an optimal layout.
David, we need to.
Are you working with storage vendors to introduce your storage services as a part of the native NAS solution itself, like as a containerized instance, for example, running on Unity or NetApp?
Let's speak to those companies if they want to do that. So we help the customer consume the data itself, and we can work with existing storage. That's what we layer on top. If someone would want OEM our technology and do that, absolutely, that would be interesting. But it's
what we've found, and what my experience has been with Fusion IO, is that in the end, when you're bringing disruptive technologies to market, it's the customers that are your friend, and generally the ones on the profit side of the business. Interestingly enough, Fusion IO sold not to the storage, not to the infrastructure guys. It was to the app folks who really needed that additional level of performance. That was one of the reasons we were successful, was not going through the OEM coming up, because that has counter incentives to the companies selling into the space. They're losing control and losing revenue because you're saving the customer money. So in the end, our focus here is to take the technology of virtualization all the way up to the point where it's self-service to the data user, and in a way where we don't need permission from the infrastructure of the cloud.
And you actually might end up making it better for the infrastructure guys, because I saw that whole thing where you said don't go over 75% capacity on the NAS.
That's right. In the end, the infrastructure folks, just like with VMware, the server vendors, it was kind of a love-hate thing, right? The server vendors looked at it wary that they were going to get consolidated. But in the end, when you improve the efficiency of the use of the resources, you're lowering the effective cost, and that taps into elasticity of demand. People find things that weren't cost-effective before that are cost-effective, and you end up expanding the demand. So you don't sell less by improving efficiency, you sell more in the end. But it can still be uncomfortable for sales teams and product development teams the product teams when they're looking at having somebody else involved in the mix. So we really don't think this kind of technology is going to come from the storage world, because they're way too focused on the infrastructure side, on the ecosystem around that, and that's one of the biggest differentiations about Hammerspace.
It's not there to make the storage admin's job easier. That's a side effect. It's there to make.
It's to make it so his job is transparent by putting the control into the data users. Exactly.